So we can simplify these radical expressions by distributing these radical expressions into each other. So we can do the distribution, this multiplication first, or we can do the division first. Either way works. In this case here, since we can distribute into this bracket, we'll do that first. So we end up with square root 2 times square root 2 gives us 2 plus square root 2 times square root 10 gives us square root 20. So inside times inside, outside times outside is the general rule for radicals. Okay, so it's all divided by 2. We can factor out the perfect square out of the square root 20. So we end up with 2 plus, factor out the 4. So square root of 4 is 2, and we're left with a factor of 5 in the square root. And then distributing the division, we can divide 2 into 2 once and 2 into 2 once. So we end up with 1 plus square root 5. And you can check these by checking out the decimal equivalents for this expression and this expression here. So here again, we can simplify this expression. First, I would simplify the fraction first before we try to add these like terms, these rational parts. So here we're gonna, since we have division across addition, we can distribute the division. So we end up with 3 root 2 plus root 3 minus, and since we want to combine like radicals, we need to put this into the mixed radical form. So we're going to factor out the square root of 9, okay, which is 3, and we're left with a factor of 3. Again, here we should divide radicals with radicals. Okay, so 360 divided by 5 is going to end up being 72. And again, you should recognize that there is a perfect square factor in the 72. So we're going to combine like terms as we go along. So we have 1 root 3 here, and we're taking away 3 root 3's. Okay, so we're going to start with 3 root 2. 1 root 3 minus 3 root 3's gives us negative 2 square root 3's. Okay, and then this expression here, root 72, we're going to factor out the perfect square of 36. So square root 36 is 6, and we're left with the factor of 2 on the inside. Okay. So the last step then is we still have like radicals, since once we reduce this into its mixed radical, lowest mixed radical form, we can see that those are 2 like radicals. We have 3 root 2's here, and again, we're just adding and subtracting or combining these like radicals. So we're just counting, so 3 root 2's plus 6 root 2's gives us 9 root 2's, and we're taking away 2 groups of root 3. So here again, we should simplify when we can. So when I see this square root 2 divided by square root 2, really that's a times and a divide root 2, so they just cancel out. Here we probably can simplify this radical part here. Okay, so I'm going to end up with 3 root 6 plus square root 14 plus 60 divided by 5 is going to give us 12. So we get square root 12 all over 2. Okay, now we should probably simplify this expression. Now this expression here, when we factor out the perfect square, okay, we're going to end up with, okay, so there are no perfect square factors involved in 6 and 14. There's a perfect square factor of 4 here, so when we factor that out, we get 2 root 3 all over 2. The 2's cancel out, and we have a 3 root 6 plus root 14 plus root 3. There are no like radicals here, so we're just going to have to leave it as that.